So now we're going to do convolution, and this is basically the continuous type of convolution. There are basically two types of convolution. One is discrete and one is continuous. Discrete is pretty much easy, that's something different. Now we're going to do continuous, which deals with two continuous signals. These is one and the same signal that I'm going to convolute it here. This is the convolution sign, I'm sorry. Right. Now there can be two given signals, but I'm taking the same signal to convolute with each other. In case there are two different signals, take the shorter signal to convolute. Now, what I'm saying is we have to flip one signal to the right. That I'll show how the process is. But the thing is, for two different signals, flip the shorter signal. Here I'm just the two signals are the same. So first step is convert t to tau. So that is h of tau that we are taking. So this will be h of tau. And then flip it to the left. Right? So flip it to the left here. You'll get this is h of minus tau. Minus 1, 1. Now multiply it by t, because the definition of convolution is f of t into h of t minus tau, or f of tau into t minus tau. It's like one and the same thing, but so we have to multiply it by t. We get here we get this is t minus 1 and t. Because we multiply this by t, this is what we get as h of minus tau here, or h of t minus tau to be precise. Now we begin the main process. We have to find the range where h of t minus tau will overlap fx of tau. We have to find overlapping regions for these two. So we do case 1, where t is less than 0. This is x of t. This is sorry about that. T minus 1 and t 0. So t is less than 0. These two don't overlap. So for t less than 0, no overlap. Now case 2. For 0 less than t less than 1. So what we're going to do is we're going to basically shift this towards the right, and we're going to see if it shifts towards the right, what are the ranges when it does overlap. So I guess if here it'll be something like this. This is x of tau, and here I'm sorry, I want to show overlap. So this is h of t minus tau. Alright, so here it is t minus 1, this is 0, t, and 1. So you can see this is the overlapping region. Now the third case, we shift this more towards right, so we get one, and we shift it towards the right. So this is the overlapping region now. So this is x of t, and this is h of tau. Sorry, not t, h of, or you can call it t minus tau. I'm sorry. You go with the definition. So this is t minus 1, and this is t. So for this case, t is greater than 1. T minus 1 is greater than 0. So this is 0. So this is the third case. Here overlap occurs between these two regions. Now the main part over here, now if you shift even more here, it won't overlap, so that case we are not taking. So the main part is the integration part. Now for this case, we integrate Now the integration is y of t is equal to integration of limits. Now the limits are the limits where it overlaps over here and overlaps over here. So y of t is integration of the limits f of t into g of t d tau. If this is f of t, g of t d tau. So here it will be integration, you can see it overlap from 0 to t, integration of 0 to t, 1 into, because both the terms are 1 here, so it is 1 into 1, both the y's are 1, d tau. So it will be t, it will be tau from 0 to t, it will be t, alright? And this is the range. Now here it will be the same thing, integration of t minus 1 to 1 d tau, alright, because 1 into 1 d tau is tau from 1 to t minus 1, we get 2 minus t, and this is the range. So we plot the real convolution graph. So here it's will be the result will be like this, I guess. So you can see 0, 0, 1 and 2. So for this region it is this answer, which is y of t is equal to t, and for this it is this answer, which is 2 minus t. Now you can see because it is minus t it goes down, if it is plus t it goes up. So it's basically a triangle. So if sometimes you get 3 cases where it overlaps, and for them you'll get a trapezoid. For one time it'll be constant. So this is basically how you do convolution.